Gravitation. First, we will learn about the Kepler's law. The first law is law of orbits. It states all planets move around the sun in an elliptical orbit, having sun at one focus of the orbit. So every planet will move around the sun in elliptical orbit, and sun will be in one focus. That's what it says. And law of areas. A line joining any planet to the sun sweeps out equal areas in equal intervals of time. That is, aerial velocity of the planet remains constant. So they are saying in equal times it will sweep out equal area. Okay, we will see about that. Next one is law of periods. The square of the period of revolution of any planet around the sun is directly proportional to the cube of its mean distance from the sun. That is t square, that is square of time period, is directly proportional to the cube of its mean distance, r cube. Okay, so that we are writing k as a proportionality constant. T square is equals to k into r cube. So period of the planet is t, mean radius is r, where k is the proportionality constant, and it has the value 2.97 into 10 power minus 19. Second square meter power minus 3. So let me say about the law of areas. When the planet is nearest to the sun, its velocity is maximum. When it is farthest, velocity is minimum. Let us see how it is. Okay, if a planet moves from A to B in a given time interval and C to D in the same time interval, then the areas ASB and CSD will be equal. This is what we have seen as law of periods. Law of areas. That is, it will sweep out equal areas in equal intervals of time. From A to B, if it is going with time t1, then in the same time t1, if this is the area, that is for C to D, if this is the area, CDS is the area, then BAS and CDS will be same. If the time is same, if both here, here also it takes time t1, here also it takes time t1, then BAS and CSD both area will be equal. So let us see this statement. When the planet is nearest to the sun, its velocity is maximum. So here its velocity will be maximum, they are saying, and here its velocity will be minimum. Okay, so only its velocity is maximum, it is going to cover this much distance. Okay, and if its velocity is minimum, it will cover only small distance. But see, this distance is larger, so anyhow the area will be same. So to make the area same, it is said, okay, when planet is nearest to the sun, its velocity is maximum. When it is farthest, its velocity is minimum. Newton's universal law of gravitation. So it says F is directly proportional to the product of masses, and it's inversely proportional to square of the radius. That is, F is equals to G m1 m2 by r square, where G is the gravitational constant. That is universal gravitational constant. Although Newton's law of gravitation applies strictly to the point masses, but it can be applied to the extended objects as well, as provided the size of the objects are small compared to the distance between them. So it is generally applicable to the point masses, but it can be extended when the distance between them is very large. Okay, even the objects are not small, then if the distances are large, then we can use the Newton's law that cases also. For example, moon and the earth are far enough apart, so that to a good approximation we can treat both as point masses and apply the law of gravitation. So we have already seen what is the concept of point mass. So here the distance between moon and the earth is very large compared to their sizes, so definitely we can apply the law of gravitation, because we can treat both of them as point masses. Spherically symmetric bodies attract external particles as if their entire mass is concentrated at their center of masses. Hence, law of gravitation is applicable to them, whatever their sizes may be. So, they are talking about the spherically symmetric bodies, and they are saying the entire mass is concentrated at the center of mass. We can take it like that, and hence we can apply the law of gravitation to them. Then if we say if this is the mass m1 and this is mass m2, and this is the force on mass 1, F12 is the force on mass 1 because of mass 2, and F21 is the force on mass 2 because of mass m1. So m2 will attract m1 in this direction, so it is in this direction. M1 will attract m2 in this direction, so the direction is in this way. And yes, and they are equal and oppositely directed, that is their magnitude is same but their direction is different. That is why we are representing it like F12 is equals to minus F21, that is we are saying their directions are different. Characteristics of gravitational forces: they are always forces of attraction, so they are always attraction forces only, there is no repulsion forces in gravitation. They form action reaction pair. Force exerted by two bodies on each other are equal in magnitude but oppositely directed. That is what we say action reaction pair, because it will be on always on two bodies and they are equal in magnitude but opposite in direction. They are central force, that is they act along the line joining the centers of two bodies. Okay, now they are independent in presence of other bodies and the properties of intervening medium. So they are independent of other bodies surrounding them, and also what is the medium they in which the bodies are present, it is independent of that one also. It is the conservative force, that is it is path independent, and it is long range unsaturated weakest force in the universe. This is important, it is the weakest force in the universe. Gravitational constant G is numerically equal to the force with which two particles of each of unit mass and placed at a unit distance apart attract each other. So we have seen F is equals to G m1 m2 by r square, and from this we are writing G equals to F r square by m1 into m2. So they are saying gravitational constant is numerically equal to the force. So G will be equals to F when they are of unit masses and placed at unit distance. If this is 1, this is 1 and this is 1, then we can say G equals to F. That is nothing but what is gravitational constant. So what is the unit of gravitational constant? So it is force. Unit of force is Newton. R square is radius square, that is meter square, and by m1 m2 both the units are kilogram, so kilogram square. So that on coming up it is kilogram power minus 2. If we are taking Newton equals to kilogram meter per second square, why we are taking like this? We know F is equals to mass into acceleration. So mass, unit of mass is kilogram, and acceleration is meter per second square. So we can take it like that also. Then we can substitute this in Newton and we are getting meter cube kilogram power minus 1 second power minus 2. Yes, if we are taking instead of Newton, if we are taking dyne centimeter, then uh, centimeter square gram power minus 2, then the unit of G will be centimeter cube G power minus 1 S power minus 2. And on calculation we get the value of G, that is universal gravitational constant, equals to 6.67 into 10 power minus 11 Newton meter square kilogram power minus 2. What is the dimensions of G? So let us see how we are writing. So for that I am using the unit F r square by m1 m2. Then what is the dimensional formula of force? It is ml t power minus 2. And how how we are getting force is equals to the dimensional formula of force is ml t power minus 2. I have shown here. Force is equals to mass into acceleration, and for mass it is kilogram, for acceleration it is meter per second square. So kilogram, how will I represent in the dimensional formula? M, mass m, meter as length L, seconds I am representing it as t power minus 2. That is what I have written here. R square I have written L square. For m1 m2 there are two masses, so I can write it as m square. So this will be m power minus 1 L power 3 t power minus 2. This is the dimension of G, dimensional formula of gravitational constant, that is universal gravitational constant. gravity, it is the force by which earth attracts a body towards its center. Acceleration due to gravity is the rate of increase of velocity of a body falling freely towards the earth. So what is gravity? It is the force by which earth attracts the body towards its center. It is nothing but the force by which earth attracts. uh, Acceleration due to gravity, we know acceleration is rate of change of velocity. Acceleration due to gravity is rate of increase of velocity uh, of a body falling freely towards the earth.